So far, we are talking about individual models. We started with unsupervised learning, then moved on to regression, and then classification techniques. Then the question is, how do we keep increasing the complexity, and if the models are not enough to handle the complexity of the decision boundary, what do we do? If linear SVM is not enough, we will go to polynomial SVM. If polynomial is not enough, then we will go to RBF kernel with SVM. We know that we cannot keep on increasing the model complexity, since more training data and more training time is required if you keep on increasing the model complexity. The second way is like feature engineering. It is a huge area called feature engineering, where we we extract some features, we build a model, we build the best possible model with this set of features. I cannot do better than this. So what I will do is I will go back to feature engineering, extract few more features and build simple model now. It is like, if our features are simple, we need a complex model. If our features are complex, our simple model can work. The third approach to this problem is divide and conquer. This is what we call it as ensemble learning. In ensemble learning, instead of learning a single complex model, now we understand what is complex. If I say a deep decision tree is complex, a neural network with many hidden units and hidden layers is complex, a SVM with RBF kernel is complex. Now you understood what do I mean by complex. Instead of learning a complex model, what we try to do is, we are going to learn many simple models called weak learners and combine them to increase the overall complexity of the model. Ensemble learning, it means it is a group of things we can look as a single collection. Typical ensemble learning looks like this, we take some input, we extract some features, we select the subset of features, we train the model again and again, we increase the complexity, and then we get the output. Now what we are trying to do is, we create ensemble of models and combine their output. Let us look at different ways to create an ensemble. First, let us look at things we cannot control in a model and things we can control. Things we cannot control comes like noise in the training inputs and cross labels. We cannot control that, and there are some constraints which are going to be there which we cannot control. But what are all the things we can control is, we can control the training sample, we can control the features that we are going to use in the model, we can change the model itself, like algorithm itself, we can change the complexity of the model, and we can change the training parameters. Here when I say complexity is different and training parameters are different, okay, I can have the same complexity and same algorithm with different training parameters like learning rate, different initialization. My models become very few. This process is called model selection. Choosing the right model or right modeling algorithm is very important, and choosing the right complexity of the modeling technique is once again important, and along with that algorithm and complexity, you need to choose the right training parameters to train the model. Okay, then you may say like, what is the best model? Is any random model which we are going to create will be okay? Otherwise, how can we build average model? Okay, we may think like, let me create a complex model, it is going to be fine. No, it is not going to be fine. Like, you may learn a very crazy neural network which might be very away from the average model. Okay, but there is no such thing called average modeling or model averaging. But what we can do is, I can create many weak learners or weak models, and I can take the average of the outputs, so that I will get the model averaging.